Imagine this. You wake up to the news that a massive asteroid, one of the most concerning ever recorded, is heading toward Earth. Scientists scramble to track its path. Headlines explode with warnings, and a single question echoes everywhere. Could this be the next extinction-level event? This isn't science fiction. This is about asteroid 2024 YR4, a space rock that, for weeks, had the world on edge. Initial calculations showed a real possibility of impact, something no one wanted to believe. But just when fears reached their peak, NASA released a shocking update. The risk has changed, but not in the way you might think. Could we really be safe now? Or is another celestial body in danger? Let's find out. It all started on December 27, 2024, when astronomers at the Atlas Observatory in Chile detected something unusual: a new asteroid, later named 2024 YR4, moving through space. At first, it seemed like just another near-Earth object, the kind scientists track all the time. But as more data came in, concerns started to grow. Initial calculations estimated a 1.3% chance that this asteroid could collide with Earth in the year 2032. While that number might seem small, in astronomical terms, it was one of the highest impact probabilities ever recorded. And then, things got worse. More observations adjusted the calculations, pushing the risk up to 3.1%. That's when the media caught on, and suddenly, 2024 YR4 was everywhere. Was this the next major impact event? Could we do anything to stop it? Scientists needed more data, fast. Predicting an asteroid's trajectory isn't as simple as spotting it in the sky and drawing a straight line. It's a process that requires time, precision, and repeated observations. Think of it like this. Imagine a tennis match. A player hits the ball, and a photographer in the audience snaps a picture. That image captures the ball at a single moment in time, but it doesn't show where it came from or where it's going. The same principle applies to asteroids. The first observation tells astronomers where the object is right now, but not its full trajectory. To calculate that, they need multiple observations over time, tracking how the asteroid moves against the background of space. This is where systems like Atlas come in. By continuously scanning the sky and feeding new data into predictive models, scientists refine their calculations. And in the case of 2024 YR4, those calculations were about to take an unexpected turn. Then, on the night of February 1920, astronomers gathered new observations of 2024 YR4, and the results changed everything. NASA's Planetary Defense Team announced that the probability of Earth impact had dropped dramatically, from 3.1% to just 0.28%. For many, this was a sigh of relief. A major asteroid strike could have catastrophic consequences, and this update seemed to take that nightmare scenario off the table. But just as scientists celebrated, a new twist emerged. While the risk to Earth had decreased, another celestial body was now in the equation: the Moon. Refined calculations revealed that 2024 YR4 now had a 1% chance of colliding with our lunar neighbor. While this percentage was still low, it was higher than most previously observed lunar impact risks. So, what does this mean? Could a collision with the Moon actually happen? And if it did, would it be just a cosmic spectacle? Or something far more significant? The answers might surprise you. Let's take a closer look. If asteroid 2024 YR4 were to collide with the Moon, the impact would be nothing short of spectacular. The Moon has no atmosphere to slow objects down, meaning the asteroid would hit at full velocity, potentially over 20 kilometers per second. The result? A massive explosion, sending debris flying into space and carving out a fresh crater on the lunar surface. But would this impact affect Earth? The short answer? Probably not. Unlike an Earth impact, there would be no firestorms, no tsunamis, and no mass extinctions. However, there could be indirect effects. A large enough impact could kick up lunar dust, potentially affecting future missions like NASA's Artemis program. It might even alter the Moon's reflectivity, subtly changing how we see it from Earth. The last time humans saw a major impact on the Moon was in 1994, when comet Shoemaker-Levy 9 crashed into Jupiter. Could we witness another celestial collision in our lifetime? Scientists are watching closely. Even though the risk of impact is low, scientists aren't taking any chances. Observatories around the world, including the powerful James Webb Space Telescope, will continue tracking 2024 YR4 in the coming months. Every new data point helps refine its trajectory, reducing uncertainties and ensuring there are no surprises in the future. But what if, one day, an asteroid does pose a real threat to Earth? That's where planetary defense strategies come in. NASA has already tested asteroid deflection with the DART mission, successfully altering the orbit of a small asteroid in 2022. Future missions could take this concept further, using kinetic impactors, gravity tractors, or even nuclear devices to change an asteroid's path before it's too late. The discovery and study of 2024 YR4 highlight why these efforts are crucial. While this asteroid may not be a danger, another one in the future could be. The more we prepare now, the better our chances of protecting Earth from a catastrophic impact. But there's one final question to consider. Are we truly ready for the next big asteroid threat? The story of asteroid 2024 YR4 is a perfect reminder of how unpredictable the universe can be. One moment, an object seems like a serious threat to Earth. The next, refined calculations reveal a different outcome, this time sparing our planet, but possibly putting the Moon in the crosshairs. This raises an important question. How prepared are we for the next asteroid that might not miss? While space agencies are working on detection and deflection technologies, the truth is that we are still in the early stages of planetary defense. Investing in these programs now could be the key to preventing a real catastrophe in the future. But what do you think? Should governments allocate more resources to asteroid defense? Do you believe we'll witness a major impact in our lifetime? Let me know your thoughts in the comments. And if you want to dive deeper into the science of asteroid deflection, check out this video next. Don't forget to like, subscribe, and stay curious about the universe.